Okay, so thus far you've gone over ionic compounds. You've talked about crisscrossing to balance the charges and also the naming of ionic compounds. And how naming an ionic compound is fairly straightforward. You really just name both the metal and the nonmetal ions, with the one thing to watch out for being that the nonmetal tends to turn into an "ide" ending. So instead of sodium chlorine, it becomes sodium chloride, or magnesium sulfate, or sorry, magnesium sulfur becomes magnesium sulfide. So they're pretty straightforward. You don't have to use prefixes like di, tri, tetra, things like that, because the naming system assumes that you can balance the charges. Now, the only thing to add to that to make it does make it a bit trickier, but the concept is exactly the same, are these things that we're going to call polyatomic ions, as well as metals with multiple charges. So far, all the ions that we've looked at have been monatomic ions, things that contain just one particle, something like sodium plus or Cl minus. Well, there are a number of species, a number of particles out there that contain many atoms, but overall have a charge. And that is what it means to be a polyatomic ion, many atom ion. In this list, I've highlighted the ones in red that are straight from the IB syllabus. It says you must know these formulas and names, and that means not only knowing the chemical formulas, but also the charges that go along with them. So you've probably heard of these things before. You've heard them used in a science class at some point, but maybe didn't know exactly what they were. So the ones that you need to know by name and formula are phosphate, sulfate, carbonate, nitrate, hydroxide, hydrogen carbonate, and ammonium. Now, I've included others on the list that I feel like, although the IB doesn't state that you should know them, they do tend to come up, and so it would not be a bad thing to know about them. So a couple things to point out. First off, notice that the way that these ions are named, they tend to be a nonmetal with oxygen, a bunch of oxygen. That's almost what every single one is. And those all the ones that you need to know really end in ate. So instead of phosphide, when phosphorus is with a bunch of oxygen as an ion, it's called phosphate. When sulfur is with a bunch of oxygen as an ion, it's called sulfate. And then carbonate, nitrate. This one should be fairly straightforward because it's carbonate. It's the same thing as carbonate, but it has hydrogen stuck onto it, so it's called hydrogen carbonate. And this is called hydroxide. This positively charged one is called ammonium, NH4+. So you do have to memorize them, you do have to know their charges, but when we actually use them in names, they really work the same way. So for this example, lithium has a 1+ charge, phosphate has a 3- charge, and therefore when we balance it, the 3 comes down here, and the 1 comes down here, and that's why the formula is Li3PO4. How would we name this? It's just the metal is called lithium, and PO4 is called phosphate. So this compound is called lithium phosphate. So it's fairly straightforward. The only thing that changes is if you have more than one of the polyatomic ion, you need to put it into parentheses. So in this example, aluminum hydroxide, aluminum has a 3+ charge, hydroxide has a 1- charge, which is why there's 1 aluminum and 3 hydroxides. But in order to show that there are 3 hydroxides, you have to put the little 3 around parentheses. That way it shows it's 3 times both the O and the H instead of just 3 times the H. That's really all there is to polyatomic ions. The other thing to include while we're at it is that some metals are either hard to know their charge based on them being in the middle of the table, or they can have multiple charges. So one of the most common examples is copper. We've seen that copper could be 1+ and copper can be 2+. And so when naming things that contain metals like this, so the most common examples are copper being copper 1, copper 2. Iron can be both 2 and 3+. Lead, Pb, can be 2+ and 4+. And tin, which is in the same column of the periodic table as lead, can be 2+ and 4+ as well. Some metals that are useful to know are silver, gold, both form 1+ ions, and zinc always forms a 2+ ion. So while the IB doesn't come out and say that they expect you to know these things, I've seen many examples that lead me to believe you do need to know the charge of silver and of zinc, and you should be aware that these can form compounds with multiple charges. So in order to deal with that, when you're doing a name, it's pretty straightforward. If a metal can have more than one charge, for example, copper down here, you have to figure out which form you're dealing with when you name it. So in this case, cyanide has a 1- charge, and there are 2 cyanides here. So that means I've got 2 minus charges. In order to be balanced, there must be 2 positive charges in this compound as well, which implies that this copper is a copper 2+, which means when I name it, I would call it copper in parentheses of Roman numeral 2 to stand for the 2+ charge on the copper, and then cyanide. So this would be called copper 2 cyanide as opposed to copper 1 cyanide. If you name something that has something like gold in it, you don't need to say gold 1 because gold is always a 1+ charge. So this would just be called gold nitrate like any other ionic compound. So we've got polyatomic ions, these ions made of many atoms. These atoms are covalently bonded together, sharing electron pairs between them, but overall they have a positive or negative charge. So polyatomic ions are rather unique. They form these charged particles that will be in ionic crystal lattices, and yet on the inside of them, they contain shared electron pairs, covalent bonds. We've also looked at metals that can have more than one charge, and so all you've got to do for metals with more than one charge is use a Roman numeral to indicate which charge you are dealing with. And we've got these 7 polyatomic ions to work on memorizing by name and by formula.